Hello students. Today we are going to start with the topic directive influence of substituents and their effect on reactivity. So this is the last topic of the unit 13 hydrocarbons. Now already in the unit we have learned that your benzene ring have the 6 hydrogens and all the 6 hydrogens are what? They are equivalent. Now, it means when we want to replace, we can replace any of the hydrogen, any one of these 6 hydrogen atoms by any substitution. Now, always when you are going to substitute, it's going to form a single mono substituted product. This mono substituted benzene, when it further goes to the substitution, then the group which is present on benzene ring, it is going to affect the incoming attacking groups. So we say the ability of a group already present in the benzene ring to direct the incoming group to a particular position is called directive influence of groups. Now what happens that a group present which is already present on the ring, it is going to has two effects. Now the number one effect is what? That is the orientation effect. Now this orientation effect, we say that substituents affect the orientation of the reaction. Now, when it is going to be a substituents, it is going to affect the orientation of the reaction, and the three possible disubstituted products will be what? It can be ortho, it can be para, or it can be meta. And they are not going to formed in equal amounts. Now, the nature of substituent which is already present on the benzene ring, it determines the position of the second substitution. Some groups direct substitution primarily to the ortho position and the para position. While some groups, what they do? They direct substitution to the meta position. In this way, we can have the two classes, that is your ortho and para directing, or they can have the meta directing. Second effect is a reactivity. Now, when we talk about in terms of the reactivity, then the substituents affect the reactivity of the aromatic ring, and some substituents are going to activate the ring. Therefore, they make it more reactive than the benzene. But on the other hand, some groups are going to deactivate the ring and they make it less reactive than benzene. For example, in aromatic nitration, OH group makes the ring more reactive than the benzene. Whereas if NO2 is substituent, then it makes the ring less reactive. On the basis of the substituents, we say that it can be classified into the three groups. The first group is going to be ortho and para-directing activators. Now, in this, we say these groups are going to release electrons. When they are going to release the electrons, what is going to happen? Your benzene ring is going to be activated. These groups direct the incoming group to the ortho and para positions. So examples of such groups are what? OH group, C, sorry, not COOH, OCH3 group, OCO, CH3, NH2, NH, uh, N, CH3, then NH, COCH3, CH3, etc. Means if this is our benzene ring, you are having electron releasing group over here, then the second substituent can come over here and over here. Means these are going to be the ortho position and this is going to be the para position. Second classification is meta directing deactivating groups. Now in this case we say that these groups are going to withdraw electrons from the benzene ring. When they are going to withdraw the electrons for benzene ring, it means they are going to deactivate the benzene ring. These groups direct the incoming group to the meta position. Now the common examples in this we have NO2 group, CN group, CHO, COOH, SO3H, COCH3. Means if we are having a benzene ring, over here we are having a electron withdrawing group, then it can have this position, that is your meta positions. The third one is your ortho and para directing deactivating groups. Now in this case, the groups withdraw electrons from the benzene ring. Withdraw electrons from the benzene ring. When it is going to withdraw, it is going to deactivate it. However, these direct the incoming group at the ortho and the para positions. Common example of such groups is fluorine, chlorine, bromine, iodine. Means your halogens. Means if your benzene ring is having a halogen group present, then it will be ortho directing and the para directing. With this, we finishes our directive influence of substituents and their effect on reactivity. Thank you. In the previous lecture, we studied about the directive influence of substituents and their effect on the reactivity. Now, we are just going to look the explanation for the different directive influence. Now, let's look it over here. Now, for the explanation, first we are going to take the example for the ortho and para directing groups. Now, in this case, we say that let us discuss it with an example. We say discuss as an example, we take a OH group, that is your phenolic group, influence of OH group over here. Now, if you're going to look the resonance structure, what it is going to be? Two lone pairs are over here. Now, what is going to happen? It is going to be electron. What the phenolic group is what? It is going to increase the electron density. So, what is going to happen? This lone pair, it is going to donate electrons over here. This will come over here. This bond will come over here. So, another structure, resonating structure will be what? Double bond will come over here. OH, it will have a lone pair. Oxygen will have the positive charge. Lone pair will come over here with the negative charge. The bonds will be here. In the second step, it is going to attack over here. Two double bonds cannot exist together, so it will come over here. These electrons are going to move over here. Now, what is going to happen in this case? It has came over here. Your electrons have moved over here. Now, these are going to attack over here. Therefore, this bond is going to shift. This. So therefore, this double bond is going to shift over here. So what will be next resonating structure? The next resonating structure will be this. And these lone pair are going to come over here. This is my resonating structure 1, 2, 3, 4, and 5. Now what is happening over here? These are the resonating structures of phenol. Now what is happening over here? It shows overall that electron density on benzene ring is increasing in comparison to the benzene. Therefore, it is what? It is a activating group. Now the typical reaction of aromatic hydrocarbons are the electrophilic substitution reaction, means electrophile are going to attack on the benzene ring. If you look over here, your structure number 2, 3 and 4. In these structures, your electron density is very high at the ortho position. This is your ortho position, and at the para position. Therefore, we say that your OH group, this OH group is what? It is a ortho and para directing group. Similarly, अगर OH group की जगह कोई और group होता, means if you take an example of the NH2 group, तब भी it is going to be ortho para directing group. Your Nr2 group, OCH3 group or CH3 group, etc. These all are going to what? These are going to be the ortho and para directing groups. Why? Because they are going to have the high electron density at this position, and this we come to know when we make the resonating structures. Second part is what? Meta directing groups, which we discussed. In the case of meta directing groups, let's look. Let's read it this also with example. Let's take the example of a nitro group. So whenever you are going to look this, we can look it on the basis of the resonating structure. Now नाइट्रो ग्रुप इज व्हाट? इट इज अ इलेक्ट्रॉन विड्रॉइंग ग्रुप, मींस ये इलेक्ट्रॉन्स यहाँ विड्रॉ होंगे. Two double bonds cannot exist together, so it will come over here, making it second structure. A positive charge is going to come over here, and positive O negative, and here also O negative. So what is going to happen? This is going to come over here. It is going to come over here, and here the positive charge will come. And its next resonating structure will be what? Nitrogen, oxygen plus. Double bond will be here and here. This will be its resonating structures. Now in this case, if you look, what is going to happen, that overall electron density on benzene ring is decreasing. Why? Because your nitro group is what? It is a deactivating group. Moreover, if you look, the electron density on ortho positions and the para positions is less than the meta position. Therefore, two meta positions are going to be rich at the electron density. Therefore, such groups are going to have the substitute on the meta positions only. Other groups, other example other than the nitro groups are what? Your carboxylic acid, sulfonic acid, cyanide group, aldehyde group, etc. These all groups are going to be a meta directing groups. Why? Because electron density will be there on the meta directing positions. The third one is the directive influence of the halogens. Now, in the case of this halogens, what is there? That your halogens are highly deactivating groups. Why? Because your halogens have the strong negative inductive effect on them. That is your minus I effect. Therefore, the electron density on benzene ring is going to decrease. But due to the resonance, the electron density on ortho and para positions is more. Therefore, we say that if any benzene ring is having a halogen over there, then it is going to be ortho and para directing. I just explain it with the help of example. For example, I am taking the chlorobenzene, this. Now what is going to happen? These electrons are, it is going to donate over here. So this bond will shift. Double bond will come over here. A positive charge will come. This will attack over here. So this bond is going to shift. Lone pair is going to come over here. Now again it is going to shift. So this bond is going to shift. In the next step, this is going to attack over here. So this bond is going to shift over, electrons are going to shift over here. Therefore, we are going to have the this resonating structure.